This is what we're going to be building in this tutorial series. Welcome to the Meme Generator. Let me tell you a little bit about myself. I'm the head of engineering at a startup called People. So allow me 45 seconds and I promise I'll time it to shamelessly plug my app. People is the ultimate social recommendation tool to discover and search for the best products, restaurants, shows, movies, books, music, etc. recommended at any time by your friends and favorite influencers. You can also collect your recommendations, grouping them by collections on your profile, and recommend to let everyone know about the products that you love. There is much more to the app that I can tell you about in 45 seconds though, so I'm gonna leave a link in the description so you can download the app today and check it out. Okie doke, let's continue. This video playlist is also meant as a companion for a written tutorial series on Medium. You can find the link for that down below. But back to the generator. The idea here is to create a site, and we'll be using Next.js for the site itself, by the way, that will make HTTP requests to the Lambdas we'll create to handle all the image processing. Once the Lambdas handle everything, we'll just download the image and that'll be it. Now, who's this tutorial series for? Well, I'll try to cater to beginners and non-beginners as much as I can. In the end, the idea is to show you how to create your first Lambda, which you'll do before this video is over, and how to give you real-world examples of how to use Lambda in production environments. Serverless, Puppeteer, and Sharp will be our biggest focus points. Well, enough chit-chat. Let's get going, peeps. Alright, so the first thing you're going to want to do is log into your AWS Management Console. Once you're there, you're either going to find Lambda under the recently visited services, or just type in Lambda under the Find Services input, and you're going to just click on it. Once that page loads, you're going to find yourself something similar to this. Maybe you have some functions already. This is the place where you're going to manage all your Lambda functions. You're going to be able to paginate, find them by tags, attributes, or whatever. So if it's empty, it's fine. Just go ahead and click on Create Function, that orange button on the top right. Once you're here, you're going to find some options. You can either author from scratch, use a blueprint, or browse the Serverless at repository. We're just going to author from scratch here. After all, this is nothing but a hello world example. So let's just type in a function name. I'm going to be using hello world HTTP. Here you can see all the available runtimes. We're just going to stick with node 12, and here you could choose or create execution roles. You don't need to mess with any of this for now, so you can just go ahead and click on create function. It's going to take from 30 seconds to a minute, so I'm just going to fast forward here a little bit. Alright, so here we are. This is our first Lambda. Down here you're going to find the code from the Lambda itself. As you can see, this is nothing but a standard boilerplate code for hello from Lambda. You can either edit the code online, upload a zip file, and upload a file from Amazon S3. To be honest though, you're probably going to end up using Serverless to deploy the Lambda straight from your Mac, PC, or whatever you use. So I wouldn't worry too much about this. If at any point you want to change the runtime, you can do it here. Maybe you want node 12, maybe you want node 10, so you can just change it here easily. And here you can change the entry point to the Lambda itself. Up here you can see that it's very easy to add triggers and destinations to how the Lambda gets activated and maybe what happens after the Lambda itself executes. But for now, we're just gonna, test that the Lambda works with a test event that's nothing but an empty object. So we just do this, click on test, and you can see it succeeded. If you click on here, you can see status code 200, body hello from Lambda. You could also click on here, and this will take you to the logs on CloudWatch. But for now, we're not gonna go there. Obviously though, you're never gonna be executing your Lambda or triggering your Lambda this way. So let's just go ahead and add a very simple trigger. After all, we're only going to be using HTTP triggers on this tutorial, so that's just very easy to set up. Let's just click here on add trigger. Once you're there, you're going to want to look for API gateway, which is the first option on the drop down. Just click on it. Here you're just going to select HTTP API. You're probably going to want to use an authorizer on production Lambdas, but for now we're just going to leave it open and we're not going to mess with additional settings at this point. And there it is. So now what this does is you got an endpoint that once it's called, you're going to be able to trigger your Lambda. So what we're going to do is we're going to go to our terminal and we're just going to use curl to make a request. So just type in curl-xget and paste the endpoint that was generated, and you should get hello from Lambda, just like we did with the test event. You also have any number of triggers you could use. Again, in this tutorial, we're only going to use API gateway, but if you go here, you can see you got S3, SNS, SQS, CloudWatch events. I mean, pretty much anything within the AWS ecosystem is going to be able to trigger a Lambda for you. If you click again here on Hello World HTTP, let's just see how easy it is to just make a change and execute it again. So we're just going to type in hello from Lambda, I don't know, my friend, whatever, I don't know. And just click save up here. You do need to click save so it updates the code. After that, we're just going to click on test once again. And we can see it succeeded once again. And voila, we have the hello from Lambda, my friend. So there you go. You created your first Lambda, executed it with success, and you didn't die trying. I think we're just going to leave it here for part 1 of this tutorial. Welcome to part 2 of this tutorial series, where by building a meme generator, we'll learn about AWS Lambda, Serverless, and much more. On this episode, we'll install Serverless using yarn or npm, download the AWS CLI and configure your credentials, create and configure our first script to use as an AWS Lambda, use the SLS package command to create a zip file to upload to our Lambda Designer function, and lastly, use the SLS deploy command to create and update our Lambdas from the comfort of our own terminal. Just as a recap, let me show you real quick what we're trying to build. The meme generator is, as the name suggests, a tool for mere mortals to upload an image and caption it in a way that resembles a meme. Once the image and the caption are set, our frontend will call our Lambda to generate the image and then trigger the download of the result. And that's basically it. That's pretty much what we're trying to build here. Let's get started. First things first, we'll make sure that we have a global install of the serverless package. To that end, open your terminal, and if you're not sure, you can type sls-help. If you get an output similar to this one, you should be fine. If you don't have it installed yet, you can simply do yarn global add serverless or npm install-g serverless to install it. As you'll see here, serverless allows for 3 different commands for you to call it, either serverless, slss, or sls. You'll see me use SLS, as it is short and sweet and is the one I'm used to, but feel free to use whichever you prefer. Next on our list is to install the AWS CLI, so we can configure and somewhat ease the deployments of our Lambdas. I'll leave a link below with instructions for each operating system. For macOS, it's the one that's on the screen. I'm not going to run it because I already have it installed and I don't want to mess anything up. Once that's done, in order to configure your account, you'll need an AWS access key and an AWS secret key. I'll leave a link to that below as well. When you have them, type AWS configure on your terminal to set that up. You'll get prompt messages asking for both keys, your preferred region, and output format. If you're like me, you'll probably need to have multiple configurations, or what they call profiles. one for your day-to-day job and one for your personal projects. Since your credentials are stored in a file that's easily accessible, imagine that it's fairly painless. Open your credentials file with your favorite editor to gain access to the file. As you can see, you can configure multiple profiles. Each profile will have its own set of keys, so whenever you're using a profile, let's say profile A, you'll be using a secret key and an access key to that profile, and whenever you deploy to that using those keys, it's going to go to that account. So that's the way they manage it. If you don't specify any profiles to the CLI or AWS dependent commands, it will simply assume you want to deploy it to the default. If you want to use any of the profiles, you'll have to be explicit about it, as you'll see when we move forward. Other than that, you'll never need to worry about this again, pretty much. I actually had forgotten about it. Now that the boring part is over, we can actually get our hands dirty. Go to the project's GitHub repository, link is down below, and clone or download it. Open the project with your preferred editor. As you'll see, it's quite bare bones for now. There's nothing but a page directory with an index.js file with the web page I've been showing you. Nothing out of this world. This being a standard, if not boilerplatey Next.js project, in the package.json file, you'll find the familiar commands you can run to start the server in development mode, production mode, or just build the project. Remember to run yarn install or npm install to install all the dependencies. Don't worry about the node modules folder, as it's already been ignored by Git. The way I like to structure my projects is for the Lambda functions to be in their own directory. So let's create a directory for that and a serverless.yaml file within. The serverless YAML file is the way we'll communicate to serverless what we intend to do. So all our settings and configuration will be found here. Let's fill this out. First, I'll type an org. I have a serverless account, and what this does is allow me to link this to my dashboard under that name. That way I can get metrics, notifications, and alerts about my functions. It's not a required setting, but I found it really helpful in the past, so I always set it now. Under that, we have service, which is the equivalent of the name of the project as far as serverless is concerned. Each service will act as an umbrella grouping the functions that pertain to it. Remember before when we were setting up our AWS credentials, you probably wondered, why do I need to even do this? Well, we have to set up now the provider, so now everything's going to tie up together. Serverless allows for many providers, Google, Azure, Amazon, so that's why we have to set this up. It's not a one and done deal. It's pretty easy to do though. All we have to do is fill the provider part of the file. That is, name AWS, the runtime, which in this case is node 12, a region of our choosing, and in my case, a profile. I want this to go to my personal AWS account, not my day-to-day job one. Lastly, we get to the main event, the function section. First, we give a name to the function, which I'll name create. A handler, which is the entry point to set function, if you remember, which files to include, in this case just create.js. A memory size, which would be the size of the RAM of the Lambda. I'm going to just input 128. A timeout in seconds, which I'm going to input 28, which is the pseudo limit for HTTP functions. And in this case, I'm also going to set a reserved concurrency of 1. What that means is that this function can only have one instance running at set time. If you don't provide a setting, you can have a concurrency of up to 1,000, depending on how many lambdas you have and how many of them have reserved concurrency. You see, each time you reserve concurrency for a function, it is subtracted from the limit of 1,000. So I suppose you could say that you can only have a maximum of 1,000 functions with reserved concurrency of 1, or 500 with a reserved concurrency of 2, and so on. So do keep that in mind. For example, if you're running a queue which sends push notifications, you don't mind it having unlimited concurrency, because it can send two push notifications at the same time. However, if you're running a cron job, which it has to run, only one each 4 hours, for example, then you will probably set a reserve concurrency of 1 because you don't want a cron job to run 2 times. So I think that's one of the logics behind it. Whenever I set up my serverless YAML file, I like to see that everything is a-okay. So let's head out to our Lambdas directory and type SLS print. Everything is okay? You should see the same config in the file printed out to you. Okay, let's create our function. Create a new file named create.js in the Lambdas directory. I'll copy and paste the contents of our previous Lambda. I've already changed the code a bit, and I'm just gonna hit save. Now for our first piece of magic, I'm gonna create a zip file that can update and replace the code in our AWS console Lambda Designer. For that, I head to the terminal and I'm gonna hit SLS package. Now you're gonna find within your project directory a new folder named .serverless. Inside this directory, there's going to be a zip file with the name of the service in our serverless YAML. The service in our case is meme generator, so that's the name of the zip file. We need that zip file, so I'm just going to drag it out so it's easier to find. I'm going to head out to the console now, and under the code entry type, I'm going to select upload that zip file and upload the file that serverless just created for us. We changed the handler, so I'm gonna update that and I'm gonna hit save. Wait a minute, I manually throttled this function before, which means is I set a reserve concurrency to 0. So what we were talking about before, you can have 1, unlimited, or 0, which would mean that the function will never run pretty much. I didn't want anyone running it by mistake since it wasn't a secure function, so that's why I had throttled it. Let's update that so we can run the function. I'm gonna click on test and voila. We have a new way of updating our Lambda functions. It's still quite cumbersome though. As the number of functions in a project expands, you can imagine this being pretty impractical. We have, I think, 140 functions in production at People, which is a startup I work for. So I cannot really imagine myself doing this whenever I want to update a function. Thankfully, there is a better way. First, I'm gonna put the zip file back where it belongs, and before I forget, I'm gonna add the serverless directory to the gitignore file. You probably noticed before that when we printed out our serverless YAML config using SLS print, there was an attribute events which an empty array. This comes to be any triggers we may want to configure, be it SQS, a cron using CloudWatch events, etc. In our case, that's going to be an HTTP request using the API gateway. So let's fill the event section. We want it to be HTTP. I'll be creating a resource, an image. So let's say it's going to be a post method. And here's the fun part. I'm going to set it to private. So private equals true. And what that's going to do is going to require an API key to call the function. How cool is that? I love that. It's not only easy to set up, but pretty much instantly you can build a secure function that requires an API key to even accept a request. As you can see here, we're going to restrict by HTTP method as well as API key. That's excellent and pretty practical as well. I'm going to set up my API key to be accessible on a global scope to the whole service. I just need to provide the API keys key. I'm going to fill up with a value and a description. I have a value that I generated previously, so I'm just going to use that one. Let me copy and paste. You can use whatever you want here. Try and make it as secure as possible, ideally. Okay, let me check. Okay, that's it. Let's run SLS print, and we can see now that the events include the setting we just set up. We should be good to go. This time, instead of using SLS package, I'm going to run SLS deploy. Serverless is gonna do its thing, and it's gonna let us know when we're set. Okay, great. We got an error here. Sorry about that. Oh, I see. I'm an idiot. I already used this API key while running tests. Let's change it. In any case, this gives us an excellent opportunity to see that serverless provides a pretty good error output and can help us solve the issue pretty quickly. Okay, having changed that, let's run SLS deploy again. Alright, that's all folks. You done did it. You create a Lambda function without having to leave the comfort of your own terminal. One interesting thing to note is that Serverless is telling me that the stage is dev, which would be the default since we didn't set any stage. This is useful, as you can imagine, having stages when you want to deploy a function to a staging environment before a production environment so you can test it. So how do we choose a stage? Well, we're going to have to add something to our file, a stage option, which will make dynamic by adding the following nomenclature, which takes in the arguments from the command line when it's run. Now let's run SLS deploy again, but this time let's use the argument production and see what happens. Okay, oh, I'm a moron. I have the same errors before. I'm gonna change it and deploy again. There it is. Now we have our stage as production. Let's go ahead and open Postman to test this out. You can also use curl or whatever you feel like using. I'm gonna copy that and paste it here. We need to set up the API key in our headers using the x-api-key header. So that's it. It works. Let's see what happens if we remove the API key. Well, we get a forbidden message. Again, pretty cool. We also set up post as the only method in our HTTP event. So what if you use get? Well, we get a weird forbidden error. I'm not sure that's entirely right, but the HTTP code is 403, so that's fine. What if we use put? We get the same error. That's great. Oh, and one last thing. Now if you go to your Lambda page on the AWS console, you'll see both functions that were deployed previously. Same name except for the stage, which is different. So the way it's constructed is, first you get the service name, meme generator, then you get the stage, be it dev or production, and then the function name. So if you have, as you get more function names, they're gonna have the same prefixes, and the only thing that's gonna change is their function name. If you have a different service, then it's gonna start different, etc., etc. If you go into the functions themselves, you can still make any changes. As with any other function, it's the same, even though it was created using serverless. I think we're going to leave it here this time around. Thanks for watching this video. If you have any comments, feedbacks, corrections, suggestions, and so on, do leave them in the comment section below. I'll see you next time.